Hi, this is The Basics, a multi-part series about all the basics to do with photography. Everything from what is a camera and how do I hold it, all the way up to how do I do post-processing. It'll be both in this studio as well as beyond these walls in the field. Join me. Alright, so welcome to lesson 2 of the basics. This one is going to be covering the idea of what is exposure and how do we expose properly on a camera. So you will often hear it described as a triangle, in particular the exposure triangle. And the three sides of the exposure triangle are ISO, or ISO, which is your sensitivity of your sensor, or your film, as the case may be. We also have aperture, which is how big the opening of the lens is. And then finally, down along the bottom, we have our shutter speed. Okay. Now, the key point is that there is a zone inside of here, which is a perfect exposure. And we are manipulating these three variables using our camera's settings in order to get our exposure inside of that perfect exposure area. That's just the basic idea. But that really doesn't tell you what those things do and what they are. I find it easiest, if you're not into optics, to consider this as an analogy if you're trying to fill a bucket with water. So let's imagine we have a bucket and we've got a spigot with a valve on it. Okay, so the water line that we want to get up to, that's our ISO. Okay, the spigot and how much we've undone that valve, that is essentially going to be our aperture. And then our shutter speed is how long we are going to wait until it fills up. Okay, so let me label this. So this is our shutter speed. And we want to get to a particular fill line. Now, as our ISO increases, our fill line is going to go lower. So the more sensitive our sensor is, the less amount of time we're going to need, and the less we're going to have to turn that crank in order to get to the desired level of water. Okay. Also, if based on how open we have the aperture and how long we have the shutter speed, if we're not hitting the fill line, we can use ISO to lower that fill line to what we need. And the same works for the others. The wider you open the lens, i.e. the more you undo the valve, the faster it's going to fill up. The less you have to use a higher ISO, i.e. you can fill up faster, quicker, so on and so forth. So this is a good analogy. However, it is important to understand some of the numbers behind the triangle. So on your camera, you will typically see your shutter speed, for example. It's going to say something like 100. Okay, so this is what it looks like on your camera, but what this is actually is 1/100th of a second. So in other words, the shutter could open and close 100 times in a second if you could run it that fast. Okay, now most cameras will go anywhere from 30 seconds, and you'll see the double tick to indicate seconds, all the way down to typically, when it comes to digital modern cameras, even the lower ends will do 1/4000th. Some will even go higher than that. The two typical that you'll see in a lot of cameras are 1/4000th and 1/8000th. And again, those will be represented by a 4000 and 8000. Whenever you see the double tick, that means you're dealing with seconds and not dealing with fractions of a second. So those are the kind of things you'll see for shutter speed. When it comes to ISO, you'll see a number like 50, 64, 100, so on and so forth. And depending on how sensitive you can make your camera sensor, it goes up from there. Now, in terms of film is usually anywhere from 50 all the way up to 800. I've seen 3200 speed film, but most of the time that is going to be very, very noisy, and so you don't want it. That's one of the drawbacks of increasing your sensitivity, is that it introduces noise. But we'll talk about that when we talk specifically about ISO in a later lesson. Now, the last one, which is by far the most confusing, because shutter speed, as the shutter speed gets shorter, you're letting in less light. As the ISO goes up, you're making it more sensitive, right? There's kind of a natural understanding of the correlation between the numbers and how dark or bright your exposure is. Aperture, however, is a little bit weird, because aperture, if you've got a particularly fast lens, and these are beginner lenses, you might have an f1.8. You'll often see it expressed like that. Well, f1.8 is bright, and as you make it dimmer, the number goes up. So, for example, if you had a lens at f22, that is going to be significantly darker than something at f1.8. Okay? Now, a related topic to this is understanding how do we tell if we're in this perfect zone. So we know that these three things interact to give us a good exposure, and we'll go into more detail in later lessons about each of these individually. But we need some way of telling how we get to that nice, perfect exposure. So we have to use something called a light meter. Okay, and the key thing about a light meter is all it does is it measures the average amount of light in the frame. Now there are several different more complicated ways of doing it, but you can generally think about it as that. It is how bright is the frame, how dark is the frame. Now, in particular, light meters, we'll talk about things in EV, which is just exposure values. And exposure values are an objective way of measuring how much light is in a scene. So what you want is you want an EV of 0. This means that according to the light meter, if we assume the light meter to be correct, then you will have a perfect exposure. Nothing is too dark, nothing is too bright. That's not always going to be the case, but that's the idea. Okay. We then, from there, can go up or down. So an EV of +1 is 2 times as bright as an EV of 0, and in the same direction, or opposite direction, excuse me. If we have EV -1, it's 2 times, or more accurately, I guess, it is half as bright as EV 0. So our exposure values, each time we up by 1 on the exposure value, we are multiplying or dividing the average amount of light in the image by 2. So, in other words, if I have something that's at EV, say, +3, so it's really bright, or what we would call overexposed, that is 8 times the light at EV0. Okay, because we multiply it by 2, multiply it by 2, and then multiply it by 2. In the same vein, if we're at -3, we are underexposed, then we will be at 1/8 of the light in EV0. The same math, divide by 2, divide by 2, divide by 2. So that's something to keep in mind, is that the exposure value scale is not a linear scale. Very much like the Richter scale, it is an exponential scale. So for example, on the Richter scale, the difference between a magnitude 3 and a magnitude 4 is not as much as the difference between a magnitude 4 and a magnitude 5, because they are dealing with something that is not a linear scale, right? It is in fact an exponential scale. So our light meter can tell us what our exposure values are, but you might be wondering, how do I know what the light meter is? What does a light meter look like? Now, if you're using a modern camera, and I'm going to assume that, there are several different things that light meters have done over the years, and different styles, different looks, different complexity levels. But most camera manufacturers have essentially created a scale that looks like this. And you'll see something like, sorry, it's usually negatives on this side, pluses on this side. This will be 0, this is -1, this is +1. So it looks kind of like a ruler, and these are exposure values, okay? So along the scale, you have indications of where particular exposure values are. Now, when you actually do a half press on your shutter button, whenever the light meter is active, you will usually see some form of cursor that's hovering above it. So in this case, the cursor is above the 0, so it is metering at 0 EV, which means it's a good exposure, right? It's a correct exposure according to the light meter. If we see it, say, over here, that means we are underexposed, and in this case, we have third lines. Sometimes you'll see half, but in this case, we've got indicators for a third of a stop, and we'll discuss what a stop is in a second, but a stop is just 1 EV value. So we're 2/3 of a stop away, so we're not quite at -1 EV for our exposure, but we're almost there. Okay, so this just tells us how far off we are from what the light meter says should be essentially neutral, right? What should be in this kind of perfect portion of our exposure triangle. So one of the things that I recommend doing is, if some of this is not clear, obviously experiment with your camera and try changing your aperture ISO and shutter speed so that you can get this cursor in the center and then take a photo. I would also recommend putting it over to one side, over to the other side. That way you can get kind of a feel for what does it mean to be overexposed, what does it mean to be underexposed. And in a lot of cases, there are times when your light meter, just due to the situation, is not going to give you an accurate reading. So what you'll want to kind of play around with that and understand that the light meter is not perfect. It's a good approximation, but it's not perfect. All right, so that is the basics of exposure. So hopefully now, if you were unfamiliar with how to get a good exposure, hopefully now you can try your hand out and see how you do. As I mentioned, we will be going over ISO, aperture, and shutter speed in later videos in more detail, as they are, each of them have their own little quirks. But yeah, so this is all you really need to know to start making good exposures. See you when I see you.